The student t-distribution. The student t-distribution with m degrees of freedom is defined to be the distribution of the ratio of a standard normal random variable to the square root of an independently distributed chi-squared random variable with m degrees of freedom divided by m. That is, let big Z be a standard normal random variable. Let big W be a random variable with a chi-squared distribution with m degrees of freedom, and let big Z and big W be independently distributed. Then the random variable big Z over the square root of big W over m has a student t-distribution, also called the t-distribution, with m degrees of freedom. This distribution is denoted T sub m. Selected percentiles of the student t-distribution are given in Appendix Table 2. The student t-distribution depends on the degrees of freedom of m. Thus, the 95th percentile of the T sub m distribution depends on the degrees of freedom m. The student t-distribution has a bell shape similar to that of the normal distribution, but it has more mass and details. That is, it is a fatter bell shape than the normal. When m is 30 or more, the student t-distribution is well approximated by the standard normal distribution, and the t sub infinity distribution equals the standard normal distribution. The F distribution. The big F distribution with m and n degrees of freedom, denoted big F sub m and n, is defined to be the distribution of the ratio of a chi-squared random variable with degrees of freedom m divided by m to an independently distributed chi-squared random variable with degrees of freedom n divided by n. To state this mathematically, let big W be a chi-squared random variable with m degrees of freedom, and let big V be a chi-squared random variable with n degrees of freedom, where big W and big V are independently distributed. Then big W over m, and put that over big V over n, has an big F sub m and n distribution. That is an big F distribution with numerator degrees of freedom m and denominator degrees of freedom n. In statistics and econometrics, an important special case of the F distribution arises when the denominator degrees of freedom is large enough that the big F sub m and n distribution can be approximated by the big F sub m and infinity distribution. In this limiting case, the denominator random variable big V over n is the mean of infinitely many squared standard normal random variables, and that mean is 1 because the mean of a squared standard normal random variable is 1. See exercise 2.4. Thus, the big F sub m and infinity distribution is the distribution of a chi-squared random variable with m degrees of freedom divided by m. Capital W over m is distributed big F sub m and infinity. For example, from Appendix Table 4, the 95th percentile of the big F sub 3 and infinity distribution is 2.60, which is the same as the 95th percentile of the chi sub 3 to the power 2 distribution, 7.81 from Appendix Table 2, divided by the degrees of freedom, which is 3. Open 7.81 divided by 3 equals 2.6. Close. The 90th, 95th, 99th percentile of the F and M in distribution are given in Appendix Table 5 for selected values of m and n.